So our last example, for all integers, n greater than equals to 3. So the domain says, hey, we're not starting at 1, we're starting at 3. The statement says 2n plus 1 is always less than 2 to the n. We're going to try to prove this. How do we prove this? We're going to use induction. So recall that in induction, we said, well, we have the very first step, which is base step. Base step, we need to show that the statement is true for the very first value in the domain. If your domain is not given, you assume that the domain is in natural numbers. But if the domain is specifically saying that, hey, all numbers greater than equals to 3, we need to check that statement for P of 3. Then we move on to inductive step. Inductive step says if pk
Professor, sorry, I accidentally muted you.
So the method of induction says if base step is true, if inductive step is true, this statement is going to be true for all numbers greater than equals to 3. Let us begin. Our base step says if I plug in 3, this inequality is met. So base step, we need to show that P of 3 is true. Remember that this statement here is your Pn. This is your statement, Pn. So P3, it means that I need to plug in 3. I get 2 times 3 plus 1 on the left-hand side. On the right-hand side, I get 2 to the third. So on the left-hand side, I have 7. On the right-hand side, I have 8. So of course, 7 is less than 8. So the very first step, the very base step is true. Okay, now inductive step. Inductive step says if pk is true, what's the meaning of pk? Pk, it means that I have to plug in k for n. 2k plus 1, if 2k plus 1 is less than 2 to k, it is true. We should be able to use this step and prove it for pk plus 1. We need to be able to prove this. Let us put a question mark on top of it. We're not sure about the result. We are trying to prove this statement. Prove that 2 times k plus 1 is also less than 2 times k plus 1. So our goal is to prove this. How do we prove this? Somehow we're going to use 2k plus 1 less than 2 to k in the process of proving this inequality. Very well. Let's take a look at this. And I have 1. Let me add 1 here. I forgot that one. There's a 1 here. Okay, perfect. So let's see. If I break this guy down, take a look at this. I'm trying to start analyzing the proof. I have to show that left-hand side is less than right-hand side. My left-hand side says I have 2k plus 1, which is 2k, plus 2, plus 1, which is 2k, plus 3. I need to show that this quantity is less than 2k plus 1. Perfect. Okay, perfect. So take a look at this. What do we have here? What I'm going to do, the proof is very easy. Let us try to break this down and use what we learned in algebra. Use algebra facts. So 2k plus 3. 2k plus 3. I'm starting from left-hand side, and try to use breaking down and using algebra fact. This can be written as 2k plus 2 plus 1. Or since you have 2k plus 1, you can switch between 1 and 2. So write it this way, 2k plus 1 plus 2. Okay. 2k plus 1 is less than 2k. This is your pk. At the same time, you have 2, which is less than 2k. So again, 2k plus 1 as pk is less than 2k. 2 is just an algebraic fact. 3 is also less than 2k. K can be 3, can be 4, can be 5. 2 is less than 2 to the third. 2 is less than 2 to the fourth. 2 is less than 2 to the fifth, and so on. So 2 is less than 2 to the k. But what is this guy here? It is saying that I have 2k plus 2k. I have 2 times 2 to the k. So this is equal to 2 times 2 to the k. I have the same base. I add the exponents. This is equal to 2k plus 1. Done.